Hi guys, good morning. Yes, can you hear me? Hello, can you hear me? Yeah, thank you. Yeah, we'll start session. Yes, previous class, all that basics, yeah, just introduction completed previous class. Yes, let me open document, Java document. Yes, introduction. Yes, yesterday class. Yes, what is software? Yes, in software, basically two categories like system software, next application software. These points were discussed. Yes, in application software, there is a front end, next back end. Java comes under front end. In front end, again two categories like languages and packages. Java comes under languages. So in language, low level, high level languages. Yes, all these points were discussed. Okay. Yes. What is system software? What is application software? Next, about front-end software, back-end software we have discussed, about language and package discussed, low level, high level language, these things were discussed. Next generation of language, different generations, low level, high level, these things were discussed. Yes, today topic is yes, difference between interpreter and compiler. Okay, so actual Java topic next. Once interpreter compiler finished here, next we'll see Java. We'll see Java. Okay. Yes, sir. To understand all the Java features, you must have the basics here, like interpreter, compiler, and languages. So for that reason, expand basics, expand all the basics. Okay. Yeah, then we'll be going to Java features. Okay. Java features next we'll discuss. So before Java features, yes, this is a interpreter and compiler concept here. So once you understand interpreter and compiler, then you can understand Java features. Otherwise, you can't understand Java features. Okay, to understand Java features, you must have yes interpreter and compiler knowledge. Otherwise, you cannot understand here. So let us see about yes. What is interpreter? What is compiler? 1 second. See here, there are high level language and low level language. High level language. What is high level language? It's a user understandable language. Low level language, it's a system understandable language. High level language, user understandable language. Low level language, system understandable language. 1 second. High level language. For example, here, D drive, test.java. Yes. 1 second. High level language. Suppose HTML code. Okay. For example, some HTML code. Say this is high level language. High level language. It's a user understandable language. User understandable language. Okay. Right? Suppose Java program. Something like this. Suppose this is some Java program. Suppose this Java program. This Java program. Yes, this is a high level language. Yes, this is high level language. User understandable language. Easy to understand. Like English language. So this is like English language. This is like English language. It's like English language. Easy to understand this one here. Easy to understand this. Like English language, very easy to understand. Okay. Here this is called as high level language. C language, Java, C++, Python, all this it's high level language. User understandable languages. Okay, all are user understandable languages. Very easy to understand. High level language. Yes, they are high level language. Okay, like English language, Okay. Yes, system can't understand this language. System cannot understand this language here. This language has to convert into binary format. Yes, every high level language instruction. Yes, every high level language instructions have to convert into binary code. Who will convert it here? Who will convert? Who will convert from who will convert from high level language to low level language? High level language to low level language. Who will convert it? Let us see that. See every high level language. See high level language, low level language. Low level language is system understandable language. Low level language, it's a system understandable language in the form of binary code, zeros and ones. Low level language, it's a system understandable language in the form of binary codes, zeros ones format, Okay. High level language, user understandable language, like English language. This is user understandable, but it's not a system understandable language. Okay. Every high level language instruction means our program instructions have to convert into binary code. All the instructions have to convert into binary code. Right? After converting into binary code, then executing, giving outputs. Now, who will convert here? Who will convert from high level language to that low level binary code? Who will convert? For this, either compiler or interpreter. Okay, either compiler or interpreter. Okay, yes, either compiler, yes, either compiler, or either compiler or interpreter, compiler or interpreter converts from, yes, high level language to, yes, low level language means binary codes. Okay, low level language, yes, low level language. Okay, so low level language, sorry, low level language like zeros ones format, like this, zeros ones format. So every high level language instruction, has to convert into binary code. Okay, who will convert here? Yes, either compiler or interpreter. Yes, let us about what is interpreter, what is compiler. Okay, what is interpreter, what is compiler? See, next, what's the difference between interpreter and compiler? The topic we'll discuss now. Okay, right? Yes, compiler, interpreter. Okay, yes, after finishing about this compiler, interpreter, next, after finishing compiler and interpreter, yes, we'll go to Java. Just wait 1 second. Hello. Good morning, sir. Fine. నేను కొంచెం ఫ్రీ అని కాల్ చేస్తాను. Yes. Yes, let us see about interpreter and compiler. So interpreter versus compiler. Let us see that. Okay. Yes, for better explanation, let me take Word documents. Yes, interpreter, compiler. What's the difference between interpreter and compiler? Yes, interpreter versus compiler. Interpreter versus compiler. Let us see about this one here. What's the difference between these two? Interpreter versus compiler. So what is interpreter? What is compiler? See, interpreter and compiler both are converting from high level language to binary codes, but there is a difference. So what's the difference between these two? Exactly what's the difference? Let us see. Okay. So what is interpreter? What is compiler? First, let us have a discussion on compiler and interpreter here. After finishing that, yes, I'll compare these two. Okay. First, let us see about interpreter. How interpreter working here? Suppose this source code. Yes, source code. Suppose source code. Yes, maybe HTML code. Maybe, yes, like some Python code or something like this. Some interpreter based language. There are some interpreter based language. All scripting languages are interpreter based. All scripting languages. All scripting languages are interpreter based. All scripting languages are interpreter based. HTML is a scripting language. Python scripting language. PHP scripting language. Perl scripting language. These are the scripting languages. Okay. On scripting language, interpreter working. On scripting language, interpreter working. Now this is scripting language. Okay. Yes, scripting language means that can be modified anytime, like English language that can be modified anytime. Okay, how interpreter working on source code? So interpreter working on source code. Yeah, this is source code. This is called a source code. This source code. One more example. 1 second. Yes, interpreter. One more example. Yes. Suppose. See this. This is. This also interpreter. Yes, Python. This is a Python code. It's a Python code. Python also interpreter based. Yes. How interpreter working on this? Now this code is called source code. So whatever the program we are writing, our program is a source code. This is called a source code. This is called a source code. It's a source code. Okay, so whatever the program we are writing, yes, our code is called a source code. Our code is called a source code. Suppose one more example. One more example. One more example. One more example. See, this is some Java program. Yeah, this is kind of source code. Yes. Yes, one of our projects. This is source code. This code is called a source code. Okay, this code is called source code. Yes, it's a high level language, like English language, right? Like English language. This code is called a source code. So what are the program we are writing? Our program is source code. Okay. Yeah, that source code has to convert into binary code. Now the source code is like English language, right? Looking like English language. All this English language has to convert into binary code. Who will do that here? Either interpreter or compiler. Now let us start with interpreter. How interpreter working? Interpreter source code. Source code. How it's working here? Okay, let me take some code here, some example. Yes. Like this. Source code. There are some statements in source code. Example, first statement. So first statement. Yes, next statement. Okay. Next statement. Yes, next statement. There are some statements. There are some statements here. There are some statements. Assume that some statements like this. Some program statements like this. Statements. So generally here every statement is ending with semicolon. So next statement, semicolon, next statement, semicolon, next statement, semicolon, next statement. Like this. All the statements. So they are the program statements. This program, maybe some program. Okay. Maybe C program or C++ or Java or HTML or Python, something like this. This some program, some code here. Yes. See how we interpreter working on this. Let us say about the interpreter here. So first of all, interpreter checking for the first line, first statement. Checking first statement, just checking first step, checking the statements. Interpreter first of all checks the statements. Interpreter checking the statements. Suppose the statement is correct. Suppose the statement is correct. The statement is correct. Then it converts into binary code. The statement converts in binary code. Interpreter checking the statement here, checking for syntax. First of all, interpreter checking for syntax. Syntax. Syntax means some rules. Syntax means some rules. Every language has some rules here, like where to start, where to end. Open double quote, close double quote. Open bracket, close double quote. Like that, there is syntax here. For example, Java program. Yes, Java program, some syntax. Syntax, something like this. Java program, suppose program starting here, ending here. Suppose some main method starting, ending like this. Next, there is a open brackets and close brackets. Open bracket, close brackets. Open double quote, close double quote, right? There are some rules here. There are some rules. See, open brackets and close brackets. Next semicolon, end of statement, semicolon, right? There's some rules. There's some rules. Nothing but syntax. It is syntax. Okay. Checking for syntax. If syntax is correct, then it converts into binary code. So interpreter checking first statement. If first statement is correct, simply converts into binary code like this. System understandable language. Okay, this is, yes, it's a high level language. That high level language instruction simply converts into binary code. Converts into binary code. If the binary code given to processor, simply it's given to processor, submitted to processor. Now processor taking that code here and generating output here. Okay, processor. Okay, right? Yes. So you get that code, binary code submitted to processor. Now processor generating outputs. Processor generating outputs. Okay, after that, so checking for next statement. 1 second. 1 second. So interpreter checking first statement. So first statement is correct. Immediately converts into binary codes and submit it to processor and generating output. See, next statement may be right or wrong. Interpreter never think about next statements. Interpreter never think about next statements. Suppose if the statement is correct, this is correct, immediately converts into binary code giving output here. After generating output, next go to second statement. Then checking for second statement. Then checking for next statements. Checking for these statements. Suppose this statement also correct. Same. This statement is correct. Same here. Converts into binary code like zeros ones format like this. After that, now this is submitted to processor. Just submitted to processor. Just submitted to processor. Yes, after generating output, simply generating outputs. That's it here. Generating outputs. Okay, right? Suppose next, after finishing that next state, checking for next state. Suppose something wrong here. Something wrong, stops. Something wrong here. Here this statement program stops here. Yes, stops here only. Something wrong, stops. Just stops here. Just stops. Will not move forward. Any error comes, simply stops. Any error is there, simply stops. Yes, interpreter. Yes, checking. Yes, first line, then generating outputs. First line checking if it is correct, generating outputs. Second line checking if it is correct, yes, convert into binary code and generating output. So line by line, checking first line and generating output. Checking second line, generating output. So it's a line by line. It's a line by line. Suppose any error comes, stops. Okay. So first line checking and execution is completed. First one completed. After that, it will go to second one. Second one checking over. Execution also completed. After finishing that statement, next go to next statement, next statement. Suppose any error comes, simply stops. Any error, just stops. This is working of interpreter here. So any error comes, just stops. Okay. Yes, it won't go to next statement. Once error comes, simply stops. This is working of interpreter. Okay, right? Let us go to compiler. How compile is working here? Let us see about compiler. Yes, how compile is working. Yes, next about compiler. Yes, about compiler. Yes, how compile is working. Yes, about compiler. About compiler. 1 second, sorry. Yes, about compiler. Source codes. Maybe some test.c program, for example, test.c program. Yes, how compiler working here. So here compiler. Like interpreter here, compiler checking statement. Suppose first statement is correct. Suppose first statement is correct here. Even correct, it won't convert into binary codes. No, it won't convert into binary codes. Okay, it won't convert into binary codes. It won't convert. 1 second. Yes, even first statement is correct, it won't convert into binary codes. No, it won't like this. It won't convert. First statement is correct, it won't convert to binary code immediately. Then go to second statement. Checking for second statement. Suppose second statement also correct. No, immediately it won't convert here. Just only for checking. Compilation process, checking all the errors. Okay, checking first one, suppose fine. Checking second one, this is also correct. Then go third one. So third one, something wrong here. Something wrong. Even error is there, it won't stop here. Go to next statement. Checking next statement also. Checking next statement. It will check for next statements. Suppose next statement is correct, then checking for next statement. Suppose next also correct, then go to next statement. Suppose next also correct, next one. Suppose something wrong here, error message. Okay, so top to bottom, yes, first statement is correct, then go to next statement. Next correct, next. Now error message. Error at third line. Error at third line. Error at third line. After that fourth one, fifth one, sixth one, seventh one. Next error at seventh line. Error at seventh line. After checking for next statement here. So eighth line. Okay, suppose correct. Next ninth line. Suppose something wrong here. Error at 10th line. Error at 10th line. So next statement. Checking for next statement. Next checking for next statement like this. Top to bottom. Compiler checks the code from top to bottom. Compiler checks the code from top to bottom. Okay, every line checking here. Okay, here error shows error. Next here error, it shows that error also. Next here error shows all the errors. Okay, here compiler checks the whole code from top to bottom. Compiler checking program from top to bottom. Compiler checks the program from top to bottom. Okay, when come to interpreter here, checking line by line, checking first line, checking second line. Suppose something wrong, stops. Something wrong, stops. That's working of interpreter here. In case of interpret line by line checking here. Line by line, checking and execution, right? Okay, any error comes, simply stops. Any error comes, one stops, means only one error. Interpreter shows only one error. But in case of compiler, what happens here? It checks from top to bottom. Compiler checks whole program from top to bottom, checking first statement, next statement, next, like this, up to end. So top to bottom, compiler checks whole program from top to bottom, checking complete program from top to bottom, and shows all the errors. Compiler shows all the errors. But interpreter is only one error. Any error comes, simply stops. Yes, in case of interpreter here, any error just stops. It won't go to next statement. No, it won't go to next statement. Once error comes, simply stops. So interpreter showing only one error. But compiler shows all the errors. Top to bottom. Compiler checks the whole code. Yes, whole code and shows all the errors. Now there are some errors. Here. Now these errors we have to correct. As a programmer, we should correct it here. Correction of this error, first error. Correction of next error. Yes, we should correct that mistakes. Our mistakes may missing semicolon, missing brackets, missing double quotes. Okay, that you have to check it. That you have to correct. Okay, after correction, no recompile. After correction, recompile. Suppose next time no error here. Okay, next time this also corrects. Yes, next time this also correct. Means everything is fine. No errors. If no errors, then what happens here? If there are errors, what happens? If no errors here, then it opens another file. If no errors, then opening another file. Just opening another file. This is opening another file. It opens another file. Okay, just opening another file. This is what test.c means. A C program code. It's a source code. Like this is like English language. Your source code, right? Source code. Okay. So checking from top to bottom. If no errors here, then opening another file. After opening another file, this whole code, maybe this is some English language, right? English language code. Okay, all this code converts in binary format. Like zeros ones format like this. Binary format. So every statement converts in binary code. Okay, and write to another file, second file. Yeah, this file is called an exe file. This file is exe file. This is exe file. This file called as exe file. So this file called as exe file. It's exe file. Okay. Yes, like this. All these codes generating binary code like this. Okay, and write to another file. Yeah, this file called as exe file. Executable file. Yes, exe. Exe means executable, means ready to execute. It's a system understandable language. Yes, generating some test.exe file. So test.c. So first of all, test.c converts to test.exe file. Test.c converts to test.exe file. Then now this test.exe file submitted to processor. Just submitted to processor. Now processor taking the exe file, just executes and generating output simply. Just generating outputs. Okay. So what is happening here? At a time, all the statements are executing here. So here in this compiler. In compiler, now how compile is working here? Yes, compiler checking whole program from top to bottom. Compile checking whole program from top to bottom and shows all the errors. And shows all the errors. Okay. Next, you have to correct errors. As a programmer, as a Java developer, you have to correct all the errors. After correction, now recompile it. Recompile. So next time no errors. If no errors, then opening another file. Opening another file. Get this complete code top to bottom. Complete code from top to bottom. From top to bottom. Converts into binary codes and write to another file. Converts into binary codes and write to another file. This file is called as exe file. So what is happening here? Compiler checking complete program from top to bottom. Compiler checking all the statements from top to bottom and shows all the errors. Suppose if no errors, generating exe file. Yes, generating one more file, exe file, result file, exe file generating. That exe file submitted to processor. Now processor giving output, right? Finally processor giving outputs. Just a processor giving output, right? Okay. So at a time this code submitting, right? At a time complete code submitted to processor and giving outputs. In case of interpreter, what is happening here? Line by line. First line conversion, then submission, then giving outputs. Second line conversion, then submission, generating output like this. Okay. So step line by line here. So this line by line checking and line by line executing, line by line giving output. So one by one. Suppose something wrong here, stops. Something wrong, stops. Something wrong, stops. Now this interpreter working. Compiler, yes, whole program from top to bottom. Whole program from top to bottom, checking all the statements. Checking all the statements if and shows all errors. Suppose if no error, whole code converts into binary codes and write to another file called as exe file. That means so compiler generating this exe file, but in case of interpreter, no exe, no another file, only source codes. So source code, for example, here for test dot some Python program file, a scripting file, that is Python or maybe HTML, something like this. Okay, yes, the source code directly executing here. Source code first statement converting and giving output, second statement converting and giving outputs. Okay, but in case of compiler based, what happens here? One more file creates, test.exe file creates. Here there is no exe file, directly executing. So first statement, next statement, directly one by one executing here. But in case of compiler, what is happening here? Generating second file called as exe file. It is generating one more file, exe file. After generating exe file, that exe file submitted to processor. Now processor taking that exe at a time executing from top to bottom. So at a time giving output, right? At a time giving outputs. Yes, this is difference between interpreter and compiler. See, interpreter and compiler both have to convert. Interpreter and compiler both have to convert from high level language to low level language. Both are doing same job, converting from high level language to low level language. Both are doing same job, but the way it's working is different. The way it's working is different. Okay. Now let us compare these two here. Yes, interpreter versus compiler. Let us see. Yes, 1 second. Interpreter versus compiler. Let us see the differences. Yes, let me take this table for easy understanding. Yes, interpreter. Yes, interpreter versus compiler. Interpreter versus compiler. Interpreter versus compiler. Correct? Yes. Interpreter versus compiler. Yes. How it's working? Let us see here. Interpreter, first difference. Interpreter. Yes, interpreter. Yes, checking codes line by line. First line, next line, line by line. Okay. Yes, checks the codes. Interpreter checking codes line by line. But compiles whole program. Yes, compiler checks whole program. Compiler checks whole program from top to bottom. Okay, so compiler checks. Yes, compiler checks whole program. Just checking. Yeah, checking whole program from top to bottom. Okay, interpreter line by line. Interpreter checking code line by line. Compiler checks the whole program from top to bottom. That first difference. Next, second difference. See, second difference here. Second difference here. Yes, when come to outputs, yes, outputs, yes, outputs, line by line. Output is 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 line by line. Yes, compiler, yes, at a time. In case of compiler, exe file generating it, that exe file at a time executes. So whole program at a time, whole program, yes, whole program at a time, whole program at a time. So interpreter output is line by line. Yes, interpreter output is line by line. Compiler output is at a time. Compiler generates exe file, that exe file executing. So at a time generating output here. At a time generating outputs. Okay, right? After that, next. In case of interpreter, any error comes, stops. Any error simply stops. Any error stops. But compiler, it won't stop. Go to next statement, next statement, next statement, all the errors. So any error, interpreter stops. That means it shows only one error. 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 Interpreter shows only one error. But compiler, yes, it shows all the errors. Okay, only one error. Interpreter shows only one error. But compiler, all the errors. Yes, all the errors. Yes, all the errors from top to bottom. It shows all errors. Errors from top to bottom, from top to bottom, from top to bottom, top to bottom, right? From top to bottom. Okay, fine. So these are differences like this. So interpreter checking line by line. Yes, compiler whole program from top to bottom checking here. Next, interpreter output line by line here. Yes, compiler whole program at a time here. At a time giving output here. Yes, interpreter only one error. Yes, it shows only one error. Reason, any error comes, stops. Any error stops. Any error stops here. But compiler is not like that here. Even error getting, go to next line. Next, all the lines here. All lines shows all the errors. Okay, it shows all the errors. Next, main difference. There is a main difference. What is main difference here? Exe file. Exe file, right? See, clearly here observe, right? Here this is, see this. This is second file, right? Second file like this. Second file. Here there is no second file, right? Only directly program code. Directly program code executes. But what happens in case of compiler based, exe file creates. Exe file creates and executes. Okay. Yes, in case of interpreter here, yes, exe file does not generate. It does not generate. It does not. Yes, it does not generate. It does not generate. Does not generate exe file. It does not generate exe file. Yes, interpreter does not generate exe file. Interpreter does not generate exe file. Yes, compiler. Yes, it generates exe file. It generates exe file. It generates exe file. So main difference here, exe file here. This is main difference. Okay. So main difference between interpreter and compiler is interpreter never generating exe file. Interpreter never generates exe file. Compiler generates exe file. Compiler generates exe file. Exe means executable file. Executable file ready to execute. Okay. Exe file in the form binary codes. Exe file in the form binary codes ready to execute. Exe file in the form binary codes ready to execute. Okay. Yes, I'll show one practical example also. I'll show it. Yes, I'll show one practical example. Yes, exe file example. I'll show one practical example. Yes, next. So you can interpreter based. So interpreter based. Yes, it won't generate exe file. Generating exe file. Next here, yes, it executes source code directly here. It executes source code directly. It executes source code directly. Source code directly here. Source code directly. Executing source code here. It executes exe file. It executes exe file. Exe file, not source code. Okay. So interpreter by source code executes directly. Okay, source code executes directly. Suppose let us go to Python program. D drive cd. Yes, Python cls dir. Suppose here this is test.py program. Yes, notepad. Yes, test.py. Yes, now this Python script, right? It's a Python script. Python script. A equal to b equal to c equal to a plus b. Addition equal to c equal to a minus b. Subtraction equal to c, right? Yes, next step. Okay. Save. Control yes, saved notepad file. exit, not directly execution here. Directly. Yes, Python. Yes. Subtraction equal to 30. Yes, addition equal to 30, subtraction minus 10. Okay, right? Now see this in this, suppose, for example, here. Yes. Something mistake. Something mistake. Save it, run it here. See the error message. Directly stopped here. Stopped executing here. Okay. Yes. Yes, comma. Suppose here some mistake. Some mistake here. Mistake. Here the program executing directly here. See the error message. Some not identified, right? Not defined. Yes, name error, something like this. Line 5. Stop it there only here. Stop it there only. Okay. See here A equal 10 executed, B equal 20 executed, next C equal this statements here stop. Stop. Stopped. Okay. Yes, stopped here. Yes, now run it. Yes, done. Completed. It's addition, subtraction completed. Okay, so this is a script. Script. Yeah, this script at any time we can modify. Now opening this, I'm adding one more statement here. Suppose one more statement like multiplication C equal to A into B. Yes, next. Yes, multiplication. I'm adding one more here. Multiplication. Yes, multiplication. Yes, multiplication is equal to C. Save. Control yes, save it. Save the notepad file, exit. Now go to command line. Yes. Now run it here. Yes, Python test.py. Yes, done. Yes, code modified and submitted. Code modified, submitted. Okay. No checking, nothing here. Yes, that will take care of checking and execution. Checking, execution, checking, execution. That interpreter takes care of that. So Python is interpreter based. That interpreter takes care of everything. Yes, now compile the base. Let us go to compile the base. So C language is compile the base. Let us go to C programming. C programming. C programming. Yes, C programming is a compiler based. Yes, if you know about this exe file concept, interpreter compiler, then you can understand Java features. That's the reason I'm explaining this concept here. Okay. Yes. So C programming, ls, suppose cdx, some x. Yes, ls. It's Linux. Linux, I'm writing some C program. ls, nothing empty here. Zreach, suppose test.c program. Test.c program. Yes, C program is hash includes stdio.h. Hash include stdio.h. Hash include stdio.h. 1 second. Hash includes, yes, that color change, right? Statement is correct, automatically change it here. So hash include stdio.h. Next, white main function, yes, starting, yes, ending. It between these writing statements. So first statements. First printf, yes, hello world, hello world, hello world, hello world, hello world, right? Hello world slash and close double quotes semicolon. Next printf, printf, yes. Yeah, welcome to Linux world. Welcome to Linux world. Welcome to Linux world. Okay, slash and yes, slash and means next line, close double quote, semicolon, that's it here. This is some C program. Control C. Sorry, Control yes. Saved. Program file is saved. Let's see the test.c program file created. Now we have to compile it here. So how to compile? cc -c test.c. First you have to compile it. Yes, somewhere error message. See this. Somewhere error message. Okay. See test.c 8th line error message, right? 8th line error. Okay. Yes, let us open that 8th line. Now correct that mistake. Print f missing, right? Yes, save. 1 second here. Suppose here missing, here missing. Okay. Yes, something like this. Okay. Save and close. Save and close. Now let us compile 1 second here. Yes, see this. This mistake, right? Here the missing here error message. Fourth line error message. Fourth line error. Read. No, correct that. Yes. Bracket this is. Okay. Yes. Next. Correct this. After correction. Yes. Recompile again here. Yes. Again one more error. One more error, right? One more error. Yes, this is semicolon, right? That semicolon missing. Okay, right? Yes, after this, no compile again here. Yes, compile. Yes. Some test.o file created. Yes, after that, now it is converting the exe file. cc -o. Suppose exe means, let us say project exe. Okay, test.o. Test.o. Okay, yes, exe file created. See, project exe file created. That exe means project exe file. Now we got exe file. Right? After getting exe file, then execution /projects. Yes, hello world, welcome to Linux world, right? Now I want to change the code. Yes, this I want to change it. Okay. Yes, in place of this one here, I want some other statements. I want to add some other statements like a Python, previously Python program. Yes, simply one statement added and executed directly, right? Directly executed. Okay, Python scripting here, directly here. Yes, in Python scripting here, just open notepad. Okay, here, add the statements, half adding statements. Yes, you can submit, right? Submit, add statements, submit. That's it. But C is not like that. Compiler based is not like that here. Okay, if any changes in the code here, you have to rebuild again here. You have to create exe file again. Okay, now let us change the code here. Gedit test.c. Test.c. Open the C program file here. After opening here, suppose let us remove this one. This statement remove here. Okay, code modified. After modification, directly can't execute .c program. .c program cannot be executed. But Python .py file directly script executed. Directly script executed, right? Directly .py file, directly program executed. But when come to C language, you can't execute program directly. You can't execute program directly because that has to convert into exe file. So first you compile it here. Yes, cc-c. Yes, compilation, compile. After compilation, yes, now regenerate exe file here. That exe same this statement, this one. Yes, exe generated ls. See project exe generated. /projects. /project, right? Yes, execute hello world, got it, right? Hello world, got it. So what is happening? Exe file generated like this. Yes, here this kind of exe file generated. Okay, in Python scripting directly, yes, the script executing, no exe file concept. Okay, in scripting language, no exe file concept. No exe directly executed. Okay, see the defense interpreter. Yes, it executes source code directly. The Python script executed directly, but comparable exe file executed. The project exe file executed. Every time of changing code, you should create exe file. Compiler based. If it is compiler based here, if it is compiler based, you should create exe file. See, here say compiler. CC means C language compiler. CC means C language compiler. It's a C language compiler. It's a C language compiler. Okay. Yes. So here compiler generates exe file and executes exe file. So if it is interpreter based, source code executes directly here. Yes, it executes source code directly, whereas compiler exe file executes. This is main difference. So main difference between interpreter and compiler. Interpreter does not generate exe file. Compiler generates exe file. Next at runtime, yes, interpreter directly source code executes, but in case of compiler, exe file executes. Right? Okay. Yes. Next. Next difference. See, all scripting languages are all scripting languages are interpreter based Okay, interpreter based. All scripting languages are interpreter based. Okay, all scripting languages are interpreter based. Okay, right? Yes, compiler, all programming languages. Yes, all programming languages are languages. All programming languages are yes, compiler based. All programming language comes under compiler based. Okay. Yes, all programming languages. Okay. Yes, compiler based examples are programming languages. All programming languages are compiler based languages. All are compiler based. Okay. Yes, all scripting languages are interpreter based. See, for this example here, scripting language examples. HTML, HTML, HTML. Next, Python, Python. So next, JavaScript, JavaScript, JavaScript. Okay, HTML, Python, JavaScript. Next, PHP coding. Next, Perl scripting. Yes, all this. These are scripting language. All the scripting languages are interpreter based. When come to compiler based language like C, C is a compiler based. C++ compiler based. Okay, .NET C actually compiler based. Compiler based. Then compiler based language. Okay, next. One more difference, if it is interpreter based here, if that code is open source, means anytime you can modify. If this code you can modify anytime. If able to modify anytime, that is called open source. It's a open source. Open source. Open source means can be modified anytime here. So it is a, yes, it is a open source. Yes, it is an open source. It's an open source. Open source. Yes, it can be modified. Yes, it can be. Yes, it can be. Yes, it can be modified. It can be modified at any time. At any time. It can be modified at any time. It can be modified at any time. At any time. But it's not an open source. Compiler based not an open source. See this. Suppose if you want to modify this, yes, this project exe, that exe file you cannot modify. That exe code you can't modify. That exe code you can't modify here. Suppose if you want to modify, you should modify the original code. That original code has to convert to exe format. Okay, you cannot modify directly here. You cannot modify directly here. Okay, right? Yes. Compiler based. Yes, it is not an open source. It is not an open source. It is not an open source here. It's not an open source. Yes, it cannot be modified. It cannot be modified. It cannot be modified. Once the build is done, you cannot modify it. It cannot be modified. So this is difference between compiler and interpreter. Yes, interpreter checking line wherein compiler is top to bottom. Next, interpreter output line wherein compiler whole program at a time. Compiler whole program at a time here. Next, it shows only one error, but compiler all the errors from top to bottom. Next, interpreter does not generate exe file. Compiler generates exe. This is main difference. Main difference between interpreter and compiler. Main difference between interpreter and compiler. Interpreter generates exe file. Compiler does not generate exe file. Compiler does not generate exe file. So this is main difference. Okay. Yes. Okay, fine. In scripting language, HTML, Python, JavaScript, PHP, Perl, all the scripting language, right? Okay, right? Next, when come to compiler-based examples, C, C++, .NET language. What is Java now? The question is, what is Java? Is it compiler-based or interpreter-based? Let us see that. Okay. Yes, 1 second. See, any language which is interpreter-based, no exe file concepts. Interpreter-based, no exe file concepts. Okay. Yes, any language which is interpreter-based, which is interpreter-based, which is interpreter-based, no exe file concept, no exe file concepts. Yes, you won't get exe file here. For example, HTML code, that HTML code executes directly, no exe file. For example, HTML code, let us go to HTML. Here this HTML code, notepad. So HTML code is like this. Notepad. Yes, right click, open, run it. Yes, it's the HTML code. So HTML code. Okay, HTML code. Submit. Okay, so HTML code simply get reset. Okay, like this HTML code. This is okay. Directly .html file, test.html file executed. Test.html file executed directly here. No exe file. No exe file here. No exe file for this, right? Okay, no exe file. So any language which is interpreter based, no exe file. Okay. For HTML, browser is an interpreter. Browser is an interpreter for HTML codes. For all the HTML, browser is an interpreter. Browser is an interpreter for the HTML codes. Browser is an interpreter. So any language which is interpreter based, no exe file concepts. Okay. Now let us come to Java. What is Java here? What is Java? What is Java? See, in case of Java, yes, okay. Suppose C is a compiler based, C++ compiler based, .NET is a compiler based. Next, HTML interpreter based, Python interpreter based. Yes, Perl interpreter based. But Java both. Java depends on both. Java depends. Java depends on both. Depends on both. Depends on both. Interpreter. Yes. Interpreter. Yes. As well as compiler. Interpreter as well as compiler. Interpreter as well as compiler. Both here. Java depending on both here. Interpreter as well as compiler. So interpreter as well as compiler. Java depends on both here. Java depends on both interpreter as well as compiler. Java depending on both interpreter as well as compiler both here, right? Yes, how it is? Let us see. Let us see. Suppose any language, you take any language except Java. Any language except Java. First source code. First source code. Maybe your C program code or something like this. Source code. First source code means your program code converts into binary code. Source code converts into binary code. Source code directly converts into binary code. Source code to binary code. So your program code, see source code. See source code, this is it's converting to binary code at then executing. Even these are same. Compile are same here. The source code is converting to binary code executing, right? Source code to binary code. Source code converted into binary code. That binary code submitted to processor and generating output. Non-generating output, right? This is any language except Java. Yes. Suppose if it is Java, what happens? If it is Java here, if it is Java code, what happens here? If it is Java, in case of Java, what happens here? Source code. Yes, source code. Yes, source code converts into bytecode first of all. Bytecode. What is bytecode? We'll discuss next. Wait. Source code converts into bytecode. After that, bytecode converts into binary code. Bytecode converts into binary code. After converting it to binary code, generating output here. Okay. So there are two stages. In Java, there are two stages. Okay. Except Java. Any language except Java. Any language except Java. Maybe C language or C++. Maybe something like this. Any language, you take any language except Java, source code directly converts into binary code. Source code directly converts into binary code and giving output, right? Yes, if it is Java, what happens here? First of all, source code converts into bytecode. What is bytecode in Java? We'll discuss next. That bytecode converts into binary code, finally generating output, right? Yes, we will convert from source code to bytecode for this compiler. Yes, this part is by the compiler, this part by the compiler, this part by the compiler. So compiler converts source code to bytecode. That means here source code, suppose there is a test.java, is a source code. This source code given to Java compiler, Java compiler. This Java compiler generates one dot class for test dot class. This dot class is a bytecode. It's a bytecode. The bytecode. It's a bytecode. What is exactly bytecode? We'll discuss next. So test.java given to Java compiler taking test.java, converting it to bytecode file like tested.class. So here all the errors taken by the compiler. In Java, errors taken by the compiler. So here errors. So all errors checking by the all errors checking by the compiler. All errors checking by the compiler. Yes. If no errors, everything is fine here. If no errors, then generates bytecode here. Generates bytecode file. Means dot class file. Just dot class file generates bytecode file. So this is compiler task. After generating bytecode file, that bytecode file has to convert into binary code here. Bytecodes. That bytecode file, bytes. Yes, bytecodes has to convert to binary code here. Bytecode converted to binary code here. Binary code. We will convert for this interpreter. Yes, interpreter will do that. Interpreter. Say interpreter. So interpreter converts bytecode to binary codes. Okay. Interpreter converts bytecode to binary code. Bytecode to binary code by the interpreter. See, source code to bytecode by the compiler. Source code to bytecode, this part by the compiler. So compiler, for example, test.java. Yes, compilation, generating dot class file. Source code to bytecode by the compiler. Yes, when come to here, This byte next is what byte code. So byte code to binary code, right? Yes, next stage byte code to binary code. So first stage is source code to byte code. Is a step one. Step one source code converted to byte code by the compiler. Step two byte code converted to binary code by the interpreter. Byte code file test dot test dot test dot class file test dot class file converts into binary code. Line by line converts into binary code. No exe file concept in Java here because interpreter runtime is interpreter, no exe file. Line by line converts into binary codes. That line by line, yes, line by line, yes, line by line, yes, converts. Line by line converts into binary codes. Binary codes, then executes. Line by line converts to binary code and executes. And generating output here. Generating outputs. That's it. Generating output, just generating output here. Generating outputs. Okay, right? So tested dot class file taken by the interpreter. Line by line converts into binary codes and generating output. So this is work of Java here. Java depending on both interpreter as well as compiler. Java depending on both. See Java errors taken by the compiler. Okay. See Java errors taken by the compiler. Taken by compiler. Errors taken by compiler. Okay. Runtime execution. Yes, runtime execution by the interpreter. Execution by interpreter. Execution by interpreter. Here, interpreter. Execution by the interpreter. So interpreter will execute this program here, right? Interpreter. Okay. So errors taken by compiler. Errors taken by the compiler. Then runtime execution by the interpreter. Okay, right? Runtime execution by the interpreter. Okay, runtime execution by the interpreter. Okay. So there are two things are working here. So compiler as well as interpreter. Java depending on both here. Java depending on both compiler interpreter. First step is compiler part. Second step is interpreter. First compiler working, next interpreter working. First compiler and then interpreter. Two things will work. In case of Java, two things will be working here. Yes, more about this concept we'll discuss in JVM. We have separate topic on JVM here. That time we'll discuss very clearly. In JVM, I'll explain once again clearly this is. So this is difference between interpreter and compiler here. Interpreter compiler difference is that. Yes, in case of Java, Java depending on both interpreter as well as compiler. Right, okay. Yes, next one more point here. See any language. Yes, that point already discussed. Any language, yes, which is interpreter based. Yes, any language which is interpreter based. Any language. See any language which is interpreter based at runtime, no exe file concepts. Any language, try to understand this point here. Try to understand this. Any language which is interpreter based at runtime, no exe file concepts. Any language which is interpreter based. Any language which is interpreter based at runtime, no exe file concepts. Okay, fine. Yes. See Java runtime is a interpreter based. Java runtime is interpreter based. Okay. See any language which is interpreter based at runtime, no exe file concepts. No Java runtime is interpreter based. Now question is here. Yes, is there any exe file concepts in Java? That is question. Okay. Is there any exe file concept in Java here? See, try to understand my question again here. Try to understand this one here. Any language which is interpreter based at runtime, no exe file concepts. Yes, runtime is interpreter based. If runtime is interpreter based, no exe file concepts. Now Java runtime is interpreter based. Java runtime is interpreter based. Now, is there any exe file concept in Java? Say yes or no. Now, as per this point here, yes, say yes or no. Is there any exe file concept in Java? Yes. Any language which is interpreter based at runtime, no exe file concepts. Interpreter based at runtime, no exe file concept here. Java runtime is interpreter based. Java runtime is a is an interpreter based. So any exe file in Java here. See Java runtime is interpreter based. If it is interpreter based, no exe file concept. If runtime is interpreter based, no exe file concept. Java runtime is interpreter based. No. Yes, sorry. Java is interpreter, runtime is interpreter based. So is there an exe file? No. There is no exe file concept in Java here. So question is, can we can we create exe file in Java? That is question here. Can we create exe file in Java here? No, we can't create because no exe file concept in Java here. Okay, no. Yes, next in Java everything is a dot class file. Everything is a dot class file. It's a dot class file. Everything is dot class file. In Java, everything is a dot class file. In Java, everything is a dot class file. In Java, everything is dot class file. Everything is dot class file. See, a dot class is not exe file. See, dot class is not exe file. Dot class is not exe file. Exe file is different. Dot class is different here. Dot class file contains bytecode. See, dot class contains bytecode. Dot class contains bytecodes. Okay, dot exe file. See, dot exe file contains binary codes. That is bytecode is binary code here. Okay, dot class contains bytecodes. Dot exe file contains binary codes. Okay, this is main difference. We have another difference also. The difference we'll see next. This is not right to discuss. We'll see next. Okay. Yes, in Java features I'll explain. Exactly what is dot class file. Next, what's the difference between dot class and exe file? The differences we'll discuss in Java. Okay. So this is about compiler and interpreter. So interpreter and compiler difference. Main difference is exe file. Interpreter does not generate exe file. Compiler generates exe file. This is main difference. Suppose when you facing interview here, yes, first of all explain about this difference here. Yes, question is what's the difference? Yes, can you differentiate interpreter and compiler? Can you differentiate? Main difference exe. First tell this answer here. Explain about this answer. Yes, interpreter does not generate exe file. Compiler generates exe file. After explain other points here. Okay, so first main point, the primary point this is. After that other points, secondary points you can explain here. Okay, right? That's all. So that's all about interpreter and compiler. So Java depending on both interpreter as compiler. Java depending on both here. Only Java depends on two things. Only Java, not others. Only Java. Suppose C language only compiler, C++ only compiler, .NET only compiler, HTML only interpreter, Python only interpreter, yes, PHP only interpreter, Perl is only interpreter. Next, JavaScript is not a Java. JavaScript is different, Java is different here. JavaScript is interpreter based. Java is depending on both here. Java is both here. Okay, Java is both. Okay, so Java depending on both interpreter and compiler. That's it here. Okay, right? Yes, next about Java features. Yes, so this is about all that introduction here. Once let me go to documents. Here, this is your document here. Your documents, that introduction to software and all this. Yes, I'll share the document. This document for you only. Yes, around 470 pages document this is. I'll share you. Yes. So till now, what are we discussed? So yesterday topic and today topic. Yesterday this was discussed. Today interpret and compare the difference, the 6 differences mentioned here. Next, Java depends on both compiler as well as interpreter here. Yes, in Java errors taken by the compiler. If no errors, then Java compiler generates dot class file. Dot class is a bytecode file. Next, Java runtime by the interpreter. Java runtime is errors taken by the compiler, runtime by the interpreter. See, source codes converts into bytecode to binary codes, only giving outputs. Source codes, bytecodes, binary codes, processor generating output, right? Okay. A source code to bytecode by the compiler, bytecode to binary code by the interpreter. Java runtime is a interpreter based. Java runtime is an interpreter based. See, any language runtime is a interpreter based. Any language runtime is a Yes, is an interpreter based. Is an interpreter based, no exe file. Okay, any language runtime is an interpreter based, no exe file. Since Java runtime is an interpreter based, no exe file concept in Java. Question is, can we create exe file in Java? Answer is no. So that's all about all that introduction. Okay, next, entering into Java, features of Java. Okay. So this topic, next class we'll discuss. Yes, next class. Tomorrow no class. Tomorrow no class, first Jan 1st. Next class, Monday. Friday, Saturday, Sunday. 3 days holidays. So next class will be on Monday. Right? Yes, any doubts, guys? Any doubts? Yes, Monday will start Java. So that introduction finished here. Monday will start Java. Java features, then Java program one by one we'll discuss. Okay, don't worry. Also, I'll explain very slowly. Each and every point I'll clear it. Okay. Next, after 2 days, coding starts. Monday, Java introduction here. Tuesday, Wednesday, coding starts. How to write Java coding? That coding will be starting here. Okay. Yes. Anything else? Any doubts? No doubts? Yes, if no doubts, yes, let us wind up session for today. So next class will be on Monday. Okay, Monday means it's a 4th. Yes, Jan 1st. Tomorrow, Jan 1st, Friday, Saturday, 2nd, 3rd, Sunday. So next Monday, next class. Okay, right? Yeah. So thank you guys. Yes, yes, wish you a advanced happy new year. Yes, advanced happy new year to all of you. So thank you guys. See you on Monday, right? Yes, wind up session. Let us wind up session.